Hi, everybody. Today we are going to do a couple different problems, but we're going to be using the same three variables throughout this entire worksheet. So the main thing we're going to talk about is force equals mass times acceleration. So essentially we're going to say F equals ma. F is force, which is represented in newtons. M is mass, which is represented in kilograms. And A is acceleration, which is represented in meters per second squared. Now, depending on your math abilities, depending on how good you are at maneuvering through these problems, here's a very simple way to be able to solve what variable you are looking for to figure out during an equation. Very simple. I just say F, and I make a little triangle, M, A. And this little diagram will kind of help navigate your way through some of these problems. So F is force, M is mass, A is acceleration. If you are looking to solve a problem and you are missing one variable, let's say the problem says an object with a mass of 2.0 kilograms accelerates at 2 meters per second when an unknown force is applied to it. So now they say, what is the amount of force? So we cover the F. When you use this diagram, it's very simple. When the letters are next to each other and you've covered the F, you now multiply. If you cover one of these letters, A or M, and they are top and bottom, you divide. So it's a real simple tool to help navigate through the problems on how to solve for some of these problems. So let's go ahead and let's solve a few of these problems with each one of the different scenarios. So now let's take a look at problem number 1. The first thing I would do is I would write out all my little variables. And the problem says, an object with a mass of 2 kilograms, 2.0 kilograms, accelerates at 2 meters per second squared. So 2.0 meters per second squared. Now what we have to solve for is our force. So in this problem, we would say, okay, force equals the mass, which is 2.0 kilograms, times the acceleration, which is 2.0 meters per second squared. Now, if you also decide to use the diagram, you would cover the F and you would see mass times acceleration. So this is a pretty simple one. And we know that force equals 2 times 2, which is 4 newtons. So that is problem number 1. So now let's take a look at another type of problem. We're going to look at number 7. Problem number 7 says, an object accelerates when a force, 6.0 newtons, is applied to it. What is the mass of the object? So once again, we list our variables. Force, mass, acceleration. And this one, they want us to find what is the mass of the object. So I would go ahead and I would cover my letter M, and I know, now it's force divided by acceleration. So we would keep that in our mind. So I list out all my stuff, and I know it said force is 6 newtons. Acceleration was 3.0 meters per second. 3.0 meters per second squared, and I have to solve for mass. So I simply set this one up. Mass equals force over acceleration, and then I rewrite it just to help myself out. Mass equals 6 newtons over acceleration, 3 meters per second squared. And so as we solve for that, we know the answer is 2, and it's mass. So mass equals 2 kilograms. So now the last type of problem I want to show you is number 13 on the worksheet. But once again, I want to list my variables: force, mass, acceleration. And it says number 13, an object with a mass of 2.0 kilograms has a force of 4 newtons. So on this one, we want to solve for acceleration. So if you get confused on how to set up the equation, you cover the letter A. And I know I have force divided by mass. So I say, okay, well, acceleration equals force divided by mass. And I just plug in my knowns. 4.0 newtons divided by 2.0 kilograms. So I know I have, the answer will be 2 meters per second squared. And the last and final thing to keep in mind is, on some of these problems, you may have it where, like as in number 3, where they give you grams, but it's not kilograms. So keep in mind, 1,000 grams is equal to 1 kilogram. 2,000 grams is equal to 2 kilograms. So you may end up having to do a conversion with a couple of these problems. That's why it's so important to take a look at the units.